Hello everyone. Today we will have another lesson about design patterns, and we will cover a few more design patterns. So let's get started. This will be a short lesson, a bit shorter than the last time, unless again you have a request for coding live, creating a design pattern. I don't mind, but it's up to you. If there is enough viewers who are interested in making a pattern, I will do 1 or 2 patterns. So let's get started. So the first design pattern that I'll talk about today is a proxy. Proxy basically encapsulates a single object under the hood. So it interacts with that object indirectly, like you interact with the object indirectly. Sometimes you need to, like, you don't need to really know all the info about the object. Like a file, you don't need to know the contents about file. The contents of file are heavy. All you need to know is metadata, for example, when you're inspecting a file. So that would be enough. File name, system modified date, file name, size, those are enough, and that's proxy. Basically, that information is carried by a proxy. And when you open a file, proxy says, hey, heavy file, give me the data, and then the heavy file will give the contents from through proxy. That's main reason why proxies are there, to encapsulate behavior of another object, heavy behavior. So sometimes we need a proxy to also, let's say, do something but a bit extra, like call a request, but at the same time log a request. So if you had a request proxy and each request passing for a request proxy would be logged, for example. And that's another valid reason why proxy exists. Now, if we look at the class diagram of proxy, you see you have both a real subject and proxy subject deriving from the same interface, meaning that both are an abstraction of the same, except that the proxy holds a real subject under the hood. Image is an example that is quite clear. It's very similar to a file. Well, image needs to be rendered, and only when the image is being rendered, it will actually create the image, load the image that we have under the hood. This will not be created and loaded until render is called, and we don't get all the memory for image because we have a proxy instead of it. Proxy who simply holds a name of image. If we need just the name to inspect an image, and if we have thousands of images that we can inspect, yet we open only one of them, proxy helps us, because proxy saves memory. Proxy saves performance. Sometimes. Use it wisely. Adapter is another pattern. Adapter is also called a wrapper. Well, it basically means that any component that we want, we can make them implement any interface that we want. We can adapt them to any interface that we want. So, like I said, wrapper is a kind of adapter which encapsulates a single object, which confirms, implements the same interface that we want. Not like proxy, which was here, which implements, like, both components implement the same interface, but like adapter. Adaptee doesn't have to implement the target interface, and that's the benefit of adapter. We can make adapter implement any interface that we want. So this is extremely great when you have a legacy component, something old, or something third party that isn't really under your control, and you really want that something to be implemented by the interface that you have. So you can use an adapter pattern. You can encapsulate, wrap it, and implement your own interface like that. Another way what you can do is you can have basically a middleman kind of class which converts uh, one interface to another. That I also call that adapter. So that kind of adapter would be literally the same as multiple plugs, you know, like an adapter for plugs, where you put a plug to one side and from the other side it comes out. Here's an example how I applied this at work. At work, I had two types of clients, Entity Client Globe and Entity Client Synergy, and they both had a unique way of interacting. They both had very different behavior, and I needed stuff from them, which I couldn't get. So I wrap them in Entity Client Globe and Entity Client Synergy. The wrappies, the adaptees were Entity Client EG and Entity Client Web. Like literally, you read those and you have no idea what's under the hood and what you expect. So I made it simple. I simplified them both, and I made them derive from the same interface, Entity Client. So I unified two unrelated entities, even though they are supposed to be related. So this is really convenient because it lets to do polymorphism even for all components, which maybe at the time were not designed against polymorphic behavior and other best practices. Decorator. Decorator is magic in my opinion. Decorator is a great pattern because you have a behavior which can be added dynamically. You see, you have a behavior which derives from some interface and a decorator which can decorate such behavior, and specific decorators which decorate those behaviors specifically, each in their own way. How does that happen? What does that mean to decorate the behavior? Well, basically with Decorator, you can stack behaviors by putting it at the start or at the end of a method. Preferably at the end. Like after something happens, you can do something more. So, for example, we can see this class diagram, right? So this is a behavior. This is just another class. It doesn't mean much. We can even wrap it if it doesn't derive from some interface. It doesn't matter. But this is a behavior. And this is a decorator which implements this behavior. So it means that it does the same as the behavior. Our decorator implements the same interface as behavior. But on top of that, it has an instance to that behavior. So when we call this method, we will also call behavior foo. So behavior will be called here, and this will call its own method also here. So this will call its own method here and behavior, and this will also call its own method here and behavior. So some people say that Inheritance+Virtual +Virtual method is Decorator. That's not true. Decorator is stackable, not once, but multiple times. So the actual Decorator, I should really show an example. This is definitely time for a code example for what a Decorator is. I will create a new project, I guess. Let's make it really fast. So I'll just put it here. Speedrun. Design patterns lesson 2. So I will try to create a decorator real fast. Here you go. First, a class. like we said, I'll give a specific example. Let's say we have a printer. A basic printer can print stuff, but only in black and white. So it has this method. And we'll say black and white print. And that's all. Very simple. Now we have an interface, iPrinter. Which also has a method print. And that's it. That's our printer. Printer implements iPrinter. Now we get another method. And we call another class, and we call it black and colored printer. Also printer decorator. So printer decorator, like we said, has a protected instance to a printer. And it's an abstract class. Abstract, public, abstract void print. So we have our this will be printer property. We don't change it, so it's read only. And we have this. What's wrong? Printer base, I guess. Right, printer decorator. iPrinter public. All right, and this printer decorator. Inherits printer decorator. Will you change the title to design path to spot 2? Yes, I will. Thank you. I forget it. Let me do it fast. Video creator dashboard. I think that's the one. Part 2. I really dislike that I need to keep changing it. I'd rather have something, I don't know. I dislike it. I changed the title. Hopefully it refreshes. Anyways, so we have two classes now, 3 classes now. The behavior that we're going to decorate and the decorator itself, the base decorator that is going to be stacked. So we have those two. And now we need to implement the print method for a color printer. So we say, let's say readLine, console.readLine, and we ask for a color. Console.WriteLine, pick color. And we pick that color. And that's it. Now let's say we need to pay for a printer before we can do anything. So when we create this printer, we will pass a price. Which will be read-only. So decimal price. Price is price. So when we call this print, we will ask for price first. Please insert price into the printer. Okay, so we will simulate that you're inserting coins. Maybe it will be int because we are expecting coins in. I don't know why I put double even though it was decimal. Price in coins. Price in coins. All right, so price money spent 0. So while money spent is less than price that we need to spend, we keep asking for, you know, input. So what do we say? Const var money more like var input is console.readline. Yeah, and then we say if input int try parse input out var money. So we say if input wasn't really you know, a number, we say, well, else we say don't fake the machine, don't cheat, because input is not a number, it's not a valid coin. Exclamation mark. Sure, and this is fine. Money spent plus equal money. Right? And this is definitely bad design. I'll move this private void charge money because the function doesn't print, it does something else, and that something needs to have a name, and that something is charge money. So we charge money. We charge money in our print function for a paid printer, and we pick a color here. So I put this here, and it's enough to demonstrate how Decorator works. So static. So now we need to demonstrate how a Decorator works. So first we create a simple printer. Basic printer. Now we need to create a colorful printer. And right, when we create color printer, we pass in the eye printer so that we know what we need to decorate. It's worthwhile having the constructor here because it will work for all of them. So my printer here will be this printer over there. And now I can do also, I forgot that I need to call printer print because I print before I pick color. Because I print before I charge money. And here I should assign a printer. So I printer, and I take in a base. And I do need a constructor here. Constructor, right. Good. And that's it. Now I can play with it. So by creating a colorful print, I press in normal printer, and now colorful printer with money. Paid colorful printer, more like. And I pass in colorful printer. And one more thing, here I'll change something. Here I will first charge money because I cannot print without charging money, so it makes sense doing that first. And the same goes here. It's not a rule which action needs to be first, it's preference. So colorful printer, we made that. Paid colorful printer. Right. So new printer, not new any printer, but paid printer. And we need to set a price per paper. We're charging really lots of money for it, so it will be 55 cents. So now if I say paid printer dot print, it should do the following. It should first say, please insert 55 into the printer. So I'll say 40. Well, it wasn't enough, so I need 5 more, 5 more, 5 more. Pick color. Then I say green. Black and white print. More like printing. So let's say, let's add something to it. Total money spent, needed, price in coins minus money spent. Right, good, all good. Pick color, printing. I'll just say printing. Right, good. Let's try again. Just more realistic. Insert 55 in the printer. So I insert 50, I insert 2, I insert 1, I insert 1, I insert 1. Done. Pick color, green. Printing. Done. So that's how Decorator works. I just had a plain printer and plain printer printed stuff. It first asked for money because that's how paid printer works. And you see paid printer first charges money and only then prints. And after that, it did what another printer did, which is color printer, which is picking a color. So I paid money, I pick color, and I print it. And that's my decorator. Pretty straightforward, pretty useful, pretty damn magical. Not something that you could achieve pretty in functional programming, and this is a design pattern really worth considering. Nice pattern. Let's continue. A few more patterns and I'm done. Okay. So Facade. Facade is another design pattern. It's called structural design pattern because it simplifies a complex structure. So we hold private composition in order to hide complex interfaces. We expose it through simple interface instead. And that's what Facade is all about. It's just a composition of multiple different, not so related objects. And we compose them and expose them through public interface. Private, complex interfaces through simple public interface. Why do we need Facade? Because it simplifies what we need to know about our domain. For example, PC, you have one button, turn on, turn off on your box. That's the whole interface. Come on, it's so simple. And even someone who has no clue, like your granny, for example, how to use a PC, most likely she will be able to turn it on because it's intuitive, it's simple. You don't need to care about all those objects under the hood. It's just the button and a computer. That's all. Flyweight. Flyweight is a design pattern that is used for saving memory. Very much like a proxy, actually. Flyweight is a bit different approach, though. You basically have an object which describes common state that all other objects can have. So if you have billions of objects, but they're all the same except one property is different. For example, their name is different, but they're all rectangles of the same size. Then Flyweight is perfect for solving a problem, how to optimize memory for storing this many objects. So another example would be, well, first let's look at the class diagram. Flyweight, you see here, you have a factory for Flyweight objects. So you have some key to create objects, Flyweight objects. And those Flyweight objects will hold reference to intrinsic state. That intrinsic state will be a reference to them, to some complex, heavy object. Some object that they share behavior with, they share state with, they share properties with. Thousands of Flyweight objects have to share something between each other to be meaningful. So concrete Flyweight shares intrinsic state between each other. And that's what Flyweight is all about. Intrinsic state being shared and extrinsic state being created, unique, and carried by a Flyweight. Unique state, intrinsic state is common, extrinsic state is for Flyweight, per Flyweight. So an example, Notepad. You have so many letters in Notepad, so many different objects, but they all have the same ASCII code. All letter A's will have the same ASCII code. All letter A's will look similar. If, let's say, Notepad doesn't even change a font, then all letter A's will have the same font. Then they will have only a different position. So it is so simple, so easy to save memory using Flyweight, because you can create one A letter, one B letter, one C letter, and so on, and then flyweight objects which simply change the location of each letter. Or maybe not even that, you just need to render a letter. You don't have to store a state of it, just render it and forget about it, like you do in console.writeLine. You don't need to remember what you printed, you just print it. So with letters it would be more simple. If you need to print letters A, B, C, you don't need to recreate them. You have them created. You just press it and a new flyweight object will be created which references A, B, and so on. That's probably also in typical keyboard writing typical letters, searching for something in PC. That's probably implemented using Flyweight. Flyweight is all around us for optimizations. If you care about optimizations for many objects, you'll probably use Flyweight if they share the same state in some way. So that's all I wanted to say for today, and please do ask questions if you have. I'll wait 2 minutes, and if there are no questions, I will end the stream. It was pretty fast. Thank you for watching, and bye bye.